what we have here is a problem of conservation of energy. The small mass m will collide with the large mass big M, and as a result of that, the two masses together will swing up and will increase in height. So their kinetic energy that they have when they're down here will be transferred into gravitational potential energy when the two are together up here. And by knowing that gravitational potential energy, we can then find out the height that the ball and the projectile reach. Now, the first thing we need to do, however, is we can't work out the kinetic energy of the two objects together without first of all calculating the velocity of the two objects together. And to do that, we need to use conservation of momentum. So conservation of momentum tells us that the momentum before is equal to the momentum after. So the momentum before, we have big M, which is not moving, so that's 0 momentum, plus little m, which has a mass little m, and a velocity that we know as well, which we'll call v, equals the combined mass of big M plus little m multiplied by our new v, let's call that v2. So let's plug in some values here. So 0.2 kilograms times 122 is equal to our combined mass here, which is 0.2 plus 12, so that's 12.2 times V2. So rearranging here, V2 becomes 0.2 times 122 divided by 12.2, which comes out as 2 meters per second. So that is the combined velocity of the two masses, the projectile and the ball, is 2 meters per second. Therefore, we can use this to consider the conservation of energy. So this tells us that kinetic energy at the bottom of the swing, as soon as the two collide, must be equal to the gravitational potential energy at the top of the swing, which is the highest point that the ball can reach with the energy that it's given. So kinetic energy is half times our combined mass, m, big M, plus little m, multiplied by v squared, is equal to, again, our combined mass, m, plus little m, times gravity, times the height, h. Now we can definitely do some cancelling here. The masses cancel out, which tells us that half v squared is equal to gh. So let us rearrange this then to find h. So h equals half v squared divided by g. Well, that's a half times 4. V is 2, so v squared is 4, divided by 10, which will finally give us, so that's 2 divided by 10, which will give us 0.2 meters. That's our final answer.